Hey guys, so I noticed that a few people were missing a particular key part of um, this limiting reactant thing that we are doing. So I wanted to come in and just kind of clarify some things. So here we have a limiting reactant problem. We're given grams of both of our reactants, grams of nitric acid, grams of copper, and we want to know grams of nitrogen monoxide here, NO. Okay. All right. First thing we need to do is get to numbers of things, get to moles of it. Remember, we can't really go through and say, like, I have, 5 pounds of bread, and how many sandwiches can I make with 5 pounds of bread? Well, it just depends how many slices that is, right? So we have to figure out how many numbers of these things we have. So to do that, we do 401.42 grams of HNO3. And then are going to convert this into moles of nitric acid. We're going to drop our grams and pick up our moles, and then do that. So what is the molecular weight of nitric acid? 63.01. Okay. 63.01. Cool. We're going to grab ourselves a calculator here. Do this. Okay. And we have 6.3707 moles of HNO3. All right, we're going to do the same thing now, but for copper. 66.98 grams of copper. And we're trying to get to moles of copper. Grams over moles. We look up the molecular weight of copper. 63.56. 546. 63546. 63546. 6546. We do ourselves the calculation. Um, 1.05 moles of copper. All right, now at this point you may think, there we go, I have this many moles of copper. It's a lot less than this many moles of HNO3. So this must be my limiting reactant. Maybe. So this is the same example as, like, if you have 7 slices of cheese and 10 slices of bread, what's your limiting reactant? You might think, I have less cheese. But remember, it takes 2 slices of bread to make a sandwich. So in truth, our bread's going to run out before our cheese does. And the way we figure that out with these type of things is we just divide by our coefficients. Divide by 8 and divide by 3. So I can take this, divide by 3, and that gets us 0.351. And up here, 3707 divided by 8. There we go. And this is going to be 1.14. And it didn't matter. It worked out this time. But that copper is indeed going to run out first. This number is the less one, okay? Limiting reactant. We did the same thing in our heads with the bread example. We have 7 slices of cheese, 10 slices of bread. What we do is, in our head, we think, okay, we have one slice of cheese per sandwich, so that's fine. But then we have 2 slices of bread per sandwich, so we have to divide 10 by 2. That's 5. 5 is less than 7, so we know that bread is going to run out first. That's exactly what we did here. Okay. What some people are doing now is they're taking this number. Let me rewrite this and say, okay, I have 1.14 or 0.351. This is the limiting reactant, so we'll use this many moles of copper, and then move forward with their stoichiometry, where copper is on bottom, nitrogen monoxide's on top, and you're going to do 3 and 2, so on and so forth, and you continue on with your stoichiometry. But remember, we have more moles of copper than this. It would be like me thinking, with the sandwich example, I divided by 2 with the bread to get, if I have 10 slices of bread, divide by 2 because I need 2 slices per sandwich. It's now 5. So now I continue on with 5 slices of bread. That doesn't work. I have 10 slices of bread. So make sure you use this number of moles, all of your moles, not what is before you've divided by the coefficient. This is the number of moles that you're going to be using in your stoich step. The other number that we calculated was just to see, is this going to run out first? Okay. Moles of copper. We now can go through. Copper's gone. We have moles of NO. What is this going to be? 15 and 16, 31 moles per gram. All right, now I'm doing the converting moles to gram step. This is going to be 31 grams per mole. If you really wanted to make sure, molar mass of NO is, there we go, 30.006. Ah, geez. I was wrong. It's not 31, it's 30. Okay, there we go. And now we can just plug and chug. Moles cancel, coppers cancel, grams of NO. Now you can plug and chug this boy. 1.05 times 2 divided by 3 times 30. 21 grams of NO. So, don't forget the things I wanted to remind you of. You're going to convert, do moles, divide by the coefficients to see which one is the less, but then use the whole number of moles you have, not what's divided, to continue on with your stoich step. This is your stoich step where you look at the mole ratios of your guys, and this is the moles to gram step where you use the molecular weight of your molecule, and then you end up with 21. Ah, geez, let's see if we're right. This is always exciting to me. Did I get it right, or did I look like a fool? Yeah, good. I got it right. So there's that. Hopefully that helped you. If you're having trouble getting these right, then yeah, there's that. All right. See you guys later.